we are looking at simultaneous equations, and we're going to look at two methods that we can use to solve these. Method one is cancelling, method two is substitution, and we're then going to look at a kind of practice exam style question at the end to apply these two methods. So what do I mean by cancelling with method one? Well, by cancelling, what we want to do is we want to basically get rid of either all of the y's or all of the x's, and so we end up with just a linear equation with just x's or just y's, and then we can then solve for that that value, right? You know, if I end up with, say, I don't know, 5x plus 2 equals 12, I can solve that, right? I know therefore x has to equal 2. If we look at this equation at the moment, there's no way to kind of hone in on what the values of x and y are. They could be anything. Right? There's actually infinitely many solutions to this equation because we've got two unknowns with only one equation, and so we want to get down to a stage where we get rid of either the x's or the y's. We can do that by either adding or subtracting multiples of one equation from another equation, and we'll see what I mean by that in a second, right? So I'm going to decide that I want just x's. I want to get rid of all the y's, and I can do that by at the moment I've got a plus 4y and I've got a minus 2y. And so what it might make sense to do is I want to basically turn this 2y into a 4y, and that will then allow me to cancel the y's out. So what I'm going to do is I'm going to take my equation 2 and I'm going to times it by 2. What that's going to give me is 16x minus 4y equals 20. And I'm going to call this equation 3. Well, now we see, right, we've kind of arrived at a nice junction, right? We've got plus 4y minus 4y, and it seems as though we should be able to then cancel out these y's, right? What it turns out we can do is we can basically take equation 1 and add it onto equation 3. So we can literally do equation 1 plus equation 3. We're going to add the left sides together and the right sides together. You might wonder, you know, how can we add a whole equation to a whole equation? You know, we're probably used to thinking of, you know, we could add 14 to the right hand side and we have to then add 14 to the left hand side. We're probably used to that kind of maths, right? It's you know, standard rearranging maths. Well, we know in this case that 14 is the exact same as x plus 4y, right? We're told it from equation 1. And so instead of writing plus 14, I can write plus x plus 4y. And because they're the same thing, they're interchangeable. So what we end up doing is basically adding the left-hand side of equation 1 and the right-hand side of equation 2 onto this new equation, onto equation 3, if that makes any sense. So what we end up with, what was that? X plus 4y. What we end up with is we do 16x plus x. That gives us 17x. We do minus 4y plus 4y, and that's going to cancel out the y's. And that's why we do this, right? That's why we do this whole thing. It's because we end up with 0y, right? Because plus 4y minus 4y just cancels out. And we end up with, what do we end up with? We end up with 14 plus 20, and that's going to give us 34. So we've got 17x equals 34. I want to get x on its own. I want to cancel out that multiplied by 17. Well, the opposite of multiplying by 17 is dividing by 17. And so I can divide by 17 on both sides. That's going to leave me with x equals 2. And now that I've got my value for x, I've got x equals 2. I can take that value, and whenever I see x, I can substitute in x equals 2. And so let's look at equation 1. You know, if I copy equation 1 down here again, I've got x plus 4y equals 14. Well, instead of x, I can put in 2 because I know x equals 2. And so what I end up with is 2 plus 4y equals 14. I can get rid of the 2. I can subtract 2 from both sides. So 4y equals 12. I can divide both sides by 4, and y equals 3. And so we get our answers, x equals 2 and y equals 3. So that's how we can use cancelling to solve simultaneous equations. Let's look at the exact same question again, but we'll do method 2. We'll do substitution this time. So substitution is, again, it's a way of basically getting rid of all the x's or all of the y's. But rather than kind of adding and subtracting entire equations from one another, it's slightly different, right? So we'll do an example, and in this case we've already got x on its own, right? We've got just x here, so it probably makes sense to get rid of this x and substitute in something to do with y in its place. So what we're going to do is I'm going to use equation 2 to allow me to do that. And so if I use equation 2, I want to get x on its own, right? I want to do a bit of maths, and I want to end up with x equals something, and then I can take that something and I can put it in for x there. So how do we get x on its own? Well, I can add 2y to both sides to take care of that minus 2y. So I get 8x equals 10 plus 2y. And I can divide both sides by 8. I get x equals 10 plus 2y divided by 8. And so that's kind of what goes in that box, right? We've kind of made x the subject of that equation. So I can then take that and I can put it into equation 1. So I'm going to copy out equation 1 down here. X plus 4y equals 14. I'm going to substitute this in for x. So what that gives us is it's going to get slightly complicated. We're going to get 10 plus 2y over 8 plus 4y equals 14. I could times everything by 8, and so I get 10 plus 2y equals 4 times 8 is 32, and 14 times 8, I'm going to be lazy and do a calculator, that gives me 112. That should be a add there. And I've now got 2y plus 32y, so I'm going to get 34y for those two, and I can take care of the 10. That's going to leave me, if I subtract 10 from both sides, I get 34y equals 102. I can divide both sides by 34, and if I do that, I get y equals 3. Again, I can then substitute that in. I actually have an equation already up here, right? That tells me exactly what x equals if I know what y equals. And so if I just copy that out down here, I know x equals 10 plus 2y over 8. And I can take that y equals 3 and put it in to that equation. And so what we end up with is x equals 10 plus 2 times 3, which is 6 over 8. And so that's going to give me 16 over 8, which gives me 2. And so again, we get the exact same results with both methods. You can probably see method 1 is slightly quicker than method 2. We use method 2 normally when we're dealing with a quadratic equation, when one of our equations are quadratic. So unfortunately, we can't just ignore method 2. We kind of get forced to use it in certain circumstances. Let's do a quick example question. So let's focus on 13 for now. And this is going to be a kind of deriving a simultaneous equations from the text. So we've got a shop selling 2 coffees and 3 cakes. And so if we were to write this in an equation, well, I've got 2 coffees, which I'm going to call coffees are going to be C, and 3 cakes. So I'm going to call cakes, it's annoying that C and C, I'm going to call cakes A. And that costs $9.95. And I also know that the same shop sells 1 coffee and 4 cakes. So 1 coffee and 4 cakes for it's for $10.35. For $10.35. That's not 10:35 a.m. £10.35. So it probably makes sense to use method 1 for this, right? Because we've got 2c here and c here. Again, if I call this like equation 1 and equation 2, what I can do is I can take my equation 2 and I can times it by 2. That's going to give me 2c plus 8a equals £20 and 70 pence. And then what we see here, right, we've got a 2c term and a 2c term. Well, I know that if I want to get rid of that 2c term, what I can do is I can take equation, we'll call this equation 3. I'm going to take equation 3 and I'm going to subtract equation 1 from it. So I'm going to do equation 3 minus equation 1. That's going to give me, well, 2c minus 2c is just nothing, right? We get 0c. 8a minus 3a gives me 5a. And £20.70 minus £9.95. I just do it on the calculator. £20.70 minus £9.95 is going to give me £10.75. I then want a on its own. I want to get just the cakes on their own. So I divide both sides by 5. And if I do that, I get £2.15. So I know a cake costs £2.15p. It's going to go there, £2.15. And I now want to work out what a coffee costs, right? I've got the cakes, that's all sorted. I need to work out my coffee as well. So there are a few different ways of doing this. You know, I could pick either equation 1, 2, or 3, and just substitute in my value for 8. I'm going to pick 2. And so if I take equation 2 and I want to make c the subject, I get c is equal to 10.35 minus 4a. And I know that a is equal to 2.15. And so I can take that value, for a, and I can put it in my equation. So that's going to give me, I might just make a bit of room, that's going to give me c is equal to 10.35 minus 4 times 2.15. Well, 4 times 2.15 is going to give me £8.60. So 10.35 minus £8.60. And that is going to be, I'm going to be super lazy to make sure I get this right. 10.35 minus £8.60 is going to leave me with £1.75. So C is 1.75. And that's our answer. So that's how we can take information from text and actually put it into simultaneous equations and then use those to solve for our unknowns. And that is simultaneous equations.